Excellent. Right, we're now recording, so we're formally up and running. Thank you all for joining so promptly, and we've got an excellent talk coming up, I'm sure, from Heather, who has, well, I count her as one of our technical wizards, in that she's previously related tales of high altitude balloon tracking, and has designed a number of the Buildathon projects that we've done up at Telford. So she's going to talk to us about using antenna analyzers. So without further ado, over to you, Heather.
Well, okay, thank you, Steve. Can you all hear me okay?
Yes.
Yeah, great, okay. So yes, I'm going to whiz through these slides because I've only got 20 minutes and I'm conscious of the fact that we want to have a Q&A session. So first off, this is a beginner's guide to antenna analysis. I'm not going to talk very much about vector network analyzers. Alan is doing a talk tomorrow on that subject, and hopefully he'll go into a lot more detail about how this NanoVNA works, which is, as we'll see, a great bit of kit. So what do we want to do? Well, we've all gone there. We've built an antenna. We've got a 5 and 9 signal report, and we thought we must have done really well. Well, yeah, but I want to put some science behind that statement. What does a signal report tell us? Well, not a great deal. 14 billion mile DX on 23 watts probably tells you that you can pretty much get a radio signal out of a bit of string. What we really want to do when we're measuring an antenna is look at the absolute radiation pattern, which means going around sensing all the different polarities, the propagation, polarization with a drone around our antenna, and then we can tell exactly what's coming out and where it's going. Problem is, obviously, that is very difficult to do. So what can we do? Well, we can use an antenna analyzer. We can look at the balance on our Yagi or dipole, and we can do some analysis of system losses, again with an antenna analyzer. And also in our arsenal are going to be simulation and field strength meters if we want to use those. So the first alert, when you use an antenna analyzer, it might tell you you've got a perfect match. And what you might actually have is just a resistor on the end of your coax, which has perfect impedance match and radiates not at all. And you also need to worry about all your losses in the system, which you won't be able to tell where they are. So you need to consider your cables, connectors, load coils, and everything else where your precious RF energy is going into heat. So beam pattern, I mentioned it a little bit earlier. This is a simulation of my 160 and 80 meter inverted V in the garden. As you can see, at 160 meters, it's got quite a nice omnidirectional beam pattern. But if we look at it at 20 meters, it's not quite so good. So when you look at this on an antenna analyzer or my ATU, it says it's got a perfect match. But as you can see, you're not going to be getting a very good radiation out to people. If they're in this direction, then yeah, you'll see them. But if they're not, yes, you're not going to be doing so well. Quick mention on balance. Again, the meter won't tell you whether you've got a good match for your balun. You need a common mode current meter for that. And plenty of good designs on the web for that sort of thing. So if you're a bit of a constructor, that's your way to go. So now we'll get a little bit into the science before we go and have a look at one or two of these things. The biggest thing we need to understand is that impedance Z, as it's called, is not just resistance, it's also capacitance and inductance. So we have a complicated representation, and it also depends on frequencies. So we've got to measure 3 parameters, our impedance, sorry, we've got two parameters, our impedance and our frequency. So going into a little more detail there, our impedance we want is 50 resistive and 0 for the reactance, the complex part. We can also represent this as a magnitude and an angle and we'll see where we're getting that kind of thing. So if you consider this 50 plus 0j to be an x and a y on a graph, then the magnitude and the angle are just what that graph looks like relative to one of the axes. So our ideal situation is our antenna measures 50 plus 0j ohms, which will give us a VSWR of 1:1, very high return loss. And of course, at all points, we want to do this for our target frequency. The other thing we're going to probably meet with these things is the scatter parameters, S parameters. So basically, an S parameter is just a complex number at a particular frequency. And usually, there are 4 possible S numbers for a 2-port device. So as I've described there, if you've just got an antenna, so you're feeding a signal into it, and you're looking at what is being reflected back out of that single port, then you've got S11, and that's the only measurement you're going to get for each frequency. If you've got a 2-port device, a test device, then you could do things like measure a filter. So here you put out the signal on one port, and you also look at what comes back on that port. So this is the same as with the 1-port system, the S11. But also you've got 2 ports, so you can look at what comes out of the filter by feeding that into your 2nd port, and this is S21. And just to be difficult, the way it's labeled is where the signals are going relative to the test equipment. So it's the S parameter for the input to the device, then the output. So S21 is the output on 1 and the input on 2, which it seems logically the wrong way around, but that's the way it works. So a little bit of a look about the problems we have with analyzers and what we need to do with them. This is a very, very simplistic view of how an antenna analyzer works. You have your port, which is at A. You put a signal in through a reference 50 ohms, and then you put it out of your device through the antenna and back into your device for ground. If you've got a perfect match, then it's just a 50 ohm voltage divider, and you get half of the signal voltage at A. If it's a capacitive or inductive, you will also see a phase shift at A relative to the signal source at the top of the 50 ohm. And from all of that, we can do the maths inside the analyzer, and we can work out this impedance, this Z parameter. But before we can do that, we have to worry about the fact that we've got bits of coax, connectors, bits of wire, all sorts of things going on between A and ground, which are going to cause us to change our measurements when we do this. So this is down to calibration, and it's a thing that is really overlooked by the majority of people, and it's actually quite important. We'll take a quick look at some of the things, but basically if we put a 50 ohm load, so that's on where we would put our antenna down this bit down here, then obviously that will help us to measure where we've got problems in our 50 ohm resistor inside our device. We could put a short on, which will give us some more information. We can look at the phase changes when we put the short and the 50 ohm load, and we can also look at using an open circuit as well. An open circuit is slightly tricky because it isn't just a case of not having anything connected, because that will have capacitance associated with the end of the connector. So you actually have to have a proper open that's designed as an open. And what that does is it creates this thing called the reference plane, which is the point at which all the measurements are being taken. And your ideal is that you calibrate everything so your reference plane is actually on the point of connection to the antenna or the system, if you're measuring stuff on the system. So a little bit about calibration sets. Here's our one. We keep them in cotton wool because they're £1,000 second hand for a set of 3. You can make your own. This is a much better form of an open than just not connecting a connector. A bit of solder can make a short, and you can buy cheap kits. And if we look at the NanoVNA, they quite often come with a little set of their own. So these homemade or cheap ones aren't great, but they do make a difference, and I do encourage everybody to go work out how to calibrate their device if they have one. So a few gotchas before we actually look at some things. You remember there's a signal source in this thing, so it is actually transmitting on your antenna. And when I had the NanoVNA running last night, I was actually receiving it on my FM receiver, which I keep running. So you are transmitting, obviously not a very high power, but you are getting signals out, so be aware of that. Correspondingly, as we found when we were on Marconi Day a couple of years ago, if you're close to a big local transmitter, you'll get a false reading because your antenna will be picking up signals that will be interfering with the signal that you're trying to use to measure it. The further you get from 50 ohms, usually the worse the accuracy of these measuring devices. And that's largely because they are mostly centered around measuring a reference device. Some, and I won't mention which one, but some of them, and not necessarily the cheaper ones, have connectors that can actually wreck calibration parts because they're not very good quality connectors. So just be aware of those. If you're going to put £1,000 calibration devices on, make sure that you've got a good analyzer to, or a good connector anyway on your analyzer. And I'm sure it's no surprise to anyone that when you're holding the antenna in a room on an antenna analyzer, it's going to be very different to when you run that antenna up a mast. So as we'll see in a bit, these things have to be considered in the environment as well. So on to our first one. This is probably one that most people will have seen, good old MFJ 259B. It's a one-port device. The antenna connects at the top here. You basically just connect your antenna, apply power carefully, and you get a reading. You set the frequency on this one, tune it, and you'll see the SWR appearing, impedance here, and you'll get a bit more information on the LCD display. For anyone who's interested, I borrowed this image from DX Engineering because I wasn't very careful when I connected power. I got it the wrong way round, and now I don't have an MFJ 259. What I do have is an AAI. These are about £100 on eBay, and they're the cheaper of the higher frequency two-port devices. As you can see, it goes up to 2.7 gigahertz. So anyone wanting to get up into the microwaves, this is a great little gadget. It's got 3 basic screens we'll take a look at in a minute. It's a two-port device. And the only really hard thing to do on it is learning how to turn it on. You press Control to hold it down, press OK, hold it for 2 seconds, let go, and then it's turned on. And it's exactly the same procedure for turning it off, but it gets me every time. So just a very quick bit about how to use it, seeing this is a talk about how to use antenna analyzers. You've got the left and right arrows. That's this one here and this one here. They select whatever it is you're going to edit, which will be in red or sometimes in blue just to be difficult. You move around with that. When you're on a number, you can start editing digits by pressing the OK button. When you've finished editing digits, you press OK again, and it goes back to editing numbers. You can change the mode with the M button. So very simple. A quick run through of how that works. We turn it on, you see a screen like this. At the moment, this 5 here is edited. So if I turn this knob at the top, I will see this digit changing. If I push the right arrow, it moves to a different digit, and I can change that. Now I've changed it. If I press the mode button, I go into the more traditional view. And we'll take a quick look at this. So this is telling us we're measuring VSWR, which is what most of us are really interested with our antenna. We're starting the sweep, that's this point here, at 407 megahertz. We're finishing the sweep, that's this point at this end of the graph, at 470 megahertz. And this marker is currently set at 434.3 megahertz. and it's telling us that the VSWR at that marker is 577. So you probably gathered that the whole thing isn't turned on. This is telling us what the battery charge is like, and this is a zoom function, so we can zoom in on this axis if we want to. You remember we talked a little bit about the complex, the R plus XJ. Well, this is why we talked about it, because here it's displaying it for this particular frequency. So you can see that with nothing connected, we've got a reasonable resistance, but we've got a horrible complex number in here. So although the resistance part is good, not great, but good, we haven't actually got an antenna attached, and it's giving us a pretty rubbish result. VSWR is rubbish, as we would expect, no antenna. I remember, I mentioned S11. Well, that's the magnitude of it in dB, so basically nothing is coming back. And remember, we mentioned how we can also represent this S number as a magnitude and as an angle. So that's a different representation of it. So that's why we need to know about these things, because if we're looking for very specific points, we'll be adjusting this number up here to get very accurately to have a look at when this actually comes to where we want it. So if we want to edit this, so here I've used these arrow keys, these ones here, to select the marker. I press OK to select a digit in it. I can change that digit, or I can press the mode button and go to a different mode. This is the third screen, the power. So I can see some stuff about the power measurements, the offsets, and so on in the antenna. Obviously, these are all pretty meaningless given that there isn't an antenna. And just to be difficult, if I press OK on this screen, rather than editing the frequency, it goes over to editing this offset number. And it does it in blue, just to be difficult. Okay, so let's have a look at a real antenna. There's one I built. It's an FM homebrew, a satellite antenna, 2-element on 2 meters. And there it is. I've set the start, set the stop, adjusted the frequency for the marker until the marker was at the bottom. And I can see that at 144.6, I've got an SWR 1.28, which isn't great. But as I point out, this is measured on my bench next to where I am. If I take it outside, the frequency goes down slightly and I get my 1.0. So there's an example of using one of these things. Brief bit about NanoVNA. As I mentioned, Alan is going to do a much more detailed talk on this, so if you want to know more about it, go to his talk tomorrow. You can see here the S21 and S11 ports. They're marked as channel 0, S11. So that's where you put a signal out and you come back into the same, that's your reflection. Or if you're measuring a filter, you come out of this one and you come back in this one, and that's you measuring your S21 port. These are ridiculously cheap. That's why they are so popular. £28 on eBay gets you a device that can do 50 kilohertz up to 900 megahertz. It doesn't do above 300 very well, but it does it perfectly okay. And you can also get a PC interface for it, so you can get all this on your PC, and you can look at Smith charts for anyone who wants to go there. Basic controls, you've got an on-off button here, and this is a push switch or a left or a right push switch. So it's basically a thumb wheel. You either push it in or you push the wheel from one side to the other. Basically, you turn it on, you've got this sort of display. Push the button to go into the menu, and you get a menu like this. Push the thing to the left or the right, you move your marker and the menu down. So I've moved it down 2 places to stimulus, which is where we go change the start and stop frequencies. Push the button again. We get into this menu within that, which in this case I'm going to change start. Push the button again. Now I've got a thing that I can just walk around, collect the numbers I want. In this case, 140 megahertz for that antenna. So I move it around, select 140 at M, pressing the button each time. I do the same for stop. Then I hit the back menu item, which is down here, and I scroll off the top, and hey presto, it jumps into action. Nothing to press to make it start. It just keeps scanning. I start to 140, stop to 170. Once I'm in this mode, if I move this button up and down, or sorry, left and right, I change the marker. This is marker 1 here, and you can see I've adjusted it. I've got an SWR 1.24 at 144.5, so slightly different reading to the other one, but pretty much the same deal. Finally, a quick look. Here's my inverted V that we looked at earlier. I've put in a purple mark so you can see where it is because it doesn't come out in the photo. Little utility program, NanoVNA Saver, has a display area here that you can type in your start and stop frequency or a center and a span. Hit the sweep button, and it gives you a trace on your PC. And there you see how it's done it. That's a magnification of that bit. That's my top band antenna tuned up, SWR about 1.1, 1.2, and about 1950. And so now we get to the questions bit. Anybody want to go over anything in any more detail?
Okay, thank you for that, Heather. There's no questions popped up yet, but does anybody have any questions? Pop them in the chat, and Heather will be able to deal with them. Looks like you have just the one question. How good is the NanoVNA, Heather?
Right. Well, for the money, it's absolutely phenomenal. £28 gets you a device that I have used. Well, you saw it in use on the PC, on the on my external antenna down at top band, and you also saw it running there on 77s and the 2 meter. It's pretty good. None of these devices are great unless you calibrate them. There's the NanoVNA, well, my one came with a calibration kit. There's a nice set of menu items. Someone's mentioned in the chat here that it's also a touch screen, so you don't have to use that little button. You can just go press the menu items. I do find it non-intuitive. It does take a little while to get used to, but once you're used to it, it's absolutely brilliant. And as you saw, £28 compared to my the AAI, it's giving me pretty close to the same readings. For a lot of these things, what you're really interested in is what's happening when you make changes, and for that, all of these devices are absolutely brilliant again. So yeah, and my answer would be it's brilliant. I'd stick with it. Yeah, certainly as an introduction, you're paying £300 for the MFJ, which is not so good. I found it to be rather unreliable, and it also seems to be a bit dependent on battery voltage as well, which
okay, Shirley's asking.
Can give you a bit of differences in your readings.
Sorry, you dropped out there, Heather. Shirley's asking about the display, and she said on hers it's showing a Smith chart. Do you have any different firmware installed?
No. When you let me just go back to. Oh, come on. Right, here we go. This menu item, I used Stimulus to change the things at the bottom here. You have all sorts of things. You can play with the markers, you can calibrate it, you can recall stuff that you've saved, you can change the configs, and you've also got a display option where you can display all sorts of different things. The SWR, this one is, or the SWR, this one is a simple one, but there are lots of different options. Yeah, it's really the world is your oyster. Yeah. yeah, it can do all sorts of different things. It's just a matter of changing the display. I tend to find when people first get involved with these things that Smith charts are a little bit too complicated. It's a great thing when you're designing circuits. It's not so useful for analysing antennas, I don't think. But each to their own. If you're familiar with Smith charts, then that's probably a way to go for you.
Next one is, as you mentioned, it's from Jeff N0MII. You mentioned common mode measurements. Any quick comment about that?
Yeah, not easy to do with the VNAs or the antenna analyzers, but easy to do with a common mode meter, which is basically just put a coil around the outside of your coax, and then you can measure the current that is flowing in the outer of the outer. If people aren't familiar with that, a normal signal, you have a signal flowing up the inner to the antenna, and then the corresponding part of the signal flows down the inner of the outer of the coax. And what you're trying to do with a balun is make sure that nothing comes down the outer of the coax, because then the coax itself will be acting as part of your antenna, and obviously your nice shaped dipole won't be a dipole if you've got the whole bit of coax as a bit of wire attached. If signals are coming down the outer. So yeah, it's quite easy to do. People make them out of these clip-on ferrites where you can just wrap a coil around that. Plenty of designs online, but they're essential to really measure your balun and get sure that you've got a balance in there to measure the common mode signals.
Next one's kind of related. It says, can one test feed with balanced lines?
You can with everything. It's always a difficult problem, because if you don't know where the signals are going in a balanced line, you really can't be sure of what the readings you're getting are. You'll still get an impedance reading and it'll still be correct. But if you remember what I was saying about what the beam pattern is, i.e. is the balance line actually balanced? And what is what are the losses in things like coax and so on, and where they are? Again, you can't get much information about that sort of thing with an antenna analyzer. I will point out that external, the 8160 antenna, is fed with ladder line almost all of the way from my shack. So yeah, you can certainly do the measurements with it, but it's not going to tell you a great deal about how your baluns and transformers into the feed line is going to be performing.
Okay, the next one. Does the NanoVNA work standalone, or does it need to be attached to a PC or such like?
No, standalone. I don't know whether I can display that. Yeah, okay. So there it is. It's plugged into a PC for charging. But if I unplug it and turn it on, there it is. I don't know whether you can see it coming up there. Not very clearly, but okay. So that's it working. If I just connected it to an antenna there, it does the thing. Works really well. And as I say, if you connect it to a PC on its USB port, it comes with its own charging cable, this funny looking connector here, which isn't a USB connector. But yeah, you can connect it to a PC and then you can do the last stuff that I showed with using it on the PC screen, which is great because, as you can see, I've taken photos of the screen here, which don't come out awfully well.
Cool. The next one is not an antenna-related question, but I've heard that the NanoVNA has a battery management problems. Any thoughts about that from Graham?
I haven't had any problems with mine. Yes, I have heard that people do have problems with them. As I say, mine seems to still charge and perform quite well. It's been on charge for a while. Yeah, it's still saying it's on full. So I haven't had any problems myself, but yeah, I have heard that there are problems with some of them.
Okay. One from Tristan. I'm tempted to say with a pair of pliers, but the question is, do you know if you need to shorten a dipole from the results of the analyzer?
Okay, so if your dipole, now I've got to get this the right way around. If its minimum SWR frequency is too low, then the dipole is too big and you need to shorten it. If your minimum is too high, then your dipole is too small and you need to start again, basically. So on this one, if I had my minimum over here, which would be a higher frequency, then the dipole would be too short. So what everyone, I guess, knows, you make your dipole, particularly if you're making a wire antenna, make it too long, and then fold the ends rather than cutting them until you get it right. Folding the ends doesn't make a great deal of difference to the beam pattern, and it does make a big difference if you overdo it. You can't add wire, but you can take it away.
Thank you very much for that one. Stuart's asked about if there's any difference between the original VNA, NanoVNA, and the one with the larger display. Is it just the display that's the difference?
Again, I don't know. I haven't got the bigger display one. I'm sure Alan will be able to give you a good answer to that one tomorrow. He's gone into a lot more in depth into this NanoVNA one. But I do believe, yeah, that they are certainly different, and I think there's a different software revision I saw somewhere. So it might be that it is actually different, but maybe Alan can help us out on that one.
Super. The next one from John over in Canada. The NanoVNA is a 2-port unit, but to measure antennas, is a single port not better?
Not really, because for things like this SWR, we are only measuring on one port. You connect the antenna to this one here, which is the S11 port. It gives out a signal, and it then measures what signal comes back, the reflection. So it's the S11. It just means that for these measurements, yeah, we're only using some of the capability of this. We're using it as an antenna analyzer rather than as a vector network analyzer. But yeah, the 2 ports gives you more features, but I don't think it would be, it's not true to say that it detracts from the features that you have on the single port.
Cool. Next one's from Mike and 2HTT. How often should you recalibrate?
Now that's a very good question. A professional using £20,000 worth of HP kit would calibrate as soon as they start their unit. They'll calibrate every time they change one of the start or stop frequencies. They'll calibrate every time they undo or do up a connector. Basically, these things change a lot when you're doing very precision measurements. For the NanoVNA, I do it, I turn the device on, let it warm up a bit, calibrate it, then I go off and do the measurements. But if I need to change to a different band, so if I went from this example on the screen here of the 2-meter band, if I went up to 70 cents, then I would recal across that range so that it was actually having calibration data on exactly the same range that I was using for my actual measurements. Another thing you might mention here is that people often put connector savers, which is basically just a male and a female. I don't know if you can see that. I have a saver on here, which is just, it's a male onto the connector on the device and a female end. And that just means that if I damage the connector or I wear that connector out, I can just take that off, throw it away and put a new one on, rather than damaging the more precision connectors that I'll find on my VNA.
Always good, always good. I think someone else has already made that point further down the questions as well. So the next one, you didn't mention the NanoVNA H4, and is your AII more intuitive?
The AII I find a lot more intuitive, yes, than this one, than the NanoVNA that I've got. I don't know anything about the difference with the H4, but I do find this idea of you click a button to select something and then you have left and right buttons and a rotating button to change values a lot more intuitive than the touch screen or the left and the right slider, I guess you'd call it, on the top of the NanoVNA. So a little bit more intuitive, but then you have to remember that the NanoVNA is doing a lot more with a lot fewer buttons. The AII has got 6 or 7 buttons equivalent, whereas the NanoVNA only has the one thing. So they're doing a good job with minimal amount of extra hardware, I guess.
Cool. Question from Jenny. The NanoVNAs are now available up to 3 gigs. Have you tried one of these?
I have not, no. I went for the AAI to get me the higher frequency. It had at the time a better reputation than the 900 megahertz range of the smaller NanoVNA. And I've also got a bigger device which I can use for these things. So no, I haven't tried the new VNAs. I've seen a few of them. They appear to be very good, and they appear to be basically providing the same kind of quality up to the higher frequencies. So yeah, I wouldn't hesitate to recommend people go with them. And the price, again, you can't go wrong with these things. Just be aware that they aren't as good as a £10,000 HP piece of equipment. But for what we do, I think they're absolutely wonderful.
The next one, maybe a slightly unfair question. They're asking about the opinion for the SDR kits product, which I'm familiar with. Jan sells a different unit, which you may or may not have had your hands on.
I have not had my hands on, so I won't comment on other manufacturers.
Okay. We've covered calibration, port savers. Have you tried to do a polar diagram with a VNA? A polar diagram, yeah, well, you can do it. I think the NanoVNA software does include, I think, well, certainly the PC side, I think, does include that kind of thing. And of course, you've got the Smith chart, which will give you some form of that in terms of the angle and the magnitude of the signal. Okay. Someone else is asking about common mode currents. We've covered that one. How does the log mag reading relate to the SWR format?
The log mag, which one are we talking about? I'm not sure.
Don't know, Sebastian. Sebastian DJ.
If we're talking about okay.
It just says, how does the log mag reading relate to the SWR format?
I'll probably be talking about this tomorrow as well.
Which... Okay, well, we'll leave that one for Alan tomorrow then.
Okay.
Actually, yes, Paul G8AQA has just pointed out we do have one of these SDR kit ones.
All right.
Yes, so I will actually comment on that because I have used it. It was a long time ago. It's 1.3 gigahertz. I think it's PC. It is PC only. It doesn't have its own screen. I had quite a lot of trouble getting the PC software to work properly. It uses the sound card mechanism to get the signals in. It is a little bit outdated now compared to these the NanoVNAs and the AAIs, but it did a good job. I used it for the first build-a-thon we did for the power meter, Steve. So all the measurements we did on the power meter were done on one of these. So yeah, it's a fine beast, but I think this particular one, which is the DG8 SAQ is perhaps a little bit long in the tooth now compared to these more modern ones.
I mean, there's lots of chatter about the different variations on the VNAs going through, and I think unless you've had every one, and it's slightly unfair to compare the different ones.
Yeah,
There was a question there. I've lost that one now.
Carl has asked, have I bought or made a case for it? I have got a 3D printer, and I've started evaluating a couple of NanoVNA cases to make on that. But at the moment, I've only used it indoors, just in its bare bones form. But I think if you're going to go outdoors with it, you probably do want to make a case for it because it is a little vulnerable.
Okay. One of the questions was, could you just go over what additional information you get out of the NanoVNA that you don't get out of the old MFJ?
Okay, so you remember we talked about these 2 ports. So the MFJ it's giving you. Let me go back. It's giving you this kind of find the right screen. That type. It's giving you that kind of parameters. So it's giving you the real and the imaginary part of the impedance at a frequency. Obviously, these VNAs are giving you a nice graphical display, so you can actually see it plotted out, and you can know where you are without manually adjusting the frequency. So here you have to manually adjust the frequency, and you can see what it is here, and you can see the SWR go up. So you're getting a lot more graphical features. The VNA also is a 2-port device, so you're getting the ability to measure things like filters by feeding the signal in to the on the NanoVNA to the S21 port here. So you come into your filter here or an amplifier and out of it here, and then you can measure what is going on in your amplifier. So a lot more features that you can do when you've got a 2-port device, because you can actually measure a lot of other things, whereas the MFJ that we just looked at is a 1-port device, so you can only really measure what goes out and what comes back in again.
Okay, Tristan's come back. How to rescue the SWR if it's already on the correct frequency? Not sure I understand that. How to I think that's rescue the SWR if it's already on the correct frequency.
I'm not sure I understand that question.
Could you give us another update on that one? I'm not sure what that question's asking. Yeah, lots of comments, not so many questions now. Reduce. How do you reduce the SWR if it's already on the correct frequency? Well, I'm not sure you can. There's always that difference between resonance and.
Need to add some tuning element.
Yeah, Paul's just shouting over if it's already at the right frequency, the main things that affect the SWR of an antenna are the shape of the feed point. And where do we go? If we go up to that antenna, so bending this, this is the feed element. Sorry, this is the feed element of the reader. If you bend that a little bit, or the 77's one there, you can find it. You can just tune it a little bit, but it's not an easy thing to do. What you can really affect with the Yagi is where that frequency point is. Yes, you're inherently limited by the design of these things. Obviously, the more elements you add, you change it. If you go for a folded dipole, this antenna, right, you can't quite see it, but this is actually a half folded dipole. And again, that changes the feed impedance.
Okay, there's a question here about measuring active devices, such as a transmitter without attenuation. I think I know the answer to that, but I'll let you.
You have to be very careful, but yes, you can. I don't know what the spec capability of the input port to the NanoVNA is, but yes, be very, very careful. I would put attenuators in, but yes, you can measure to some extent by doing that kind of thing, but not, as we've said, in SWR. You have to measure the S21 parameters.
Super. It's not a question about the analyzers per se, but somebody's asking what design your satellite antenna is.
What design? That's a good question. It's Ken Britton's original design. This is a filter combiner here, 70 sems up here, obviously, and 2 meter here. And it's a folded dipole, so it's a single wire here, and this is a folded dipole that comes back on itself on this half. And it just makes a very lightweight pointable antenna that I can work the FM sats on my handy.
Cool. Right, well, look, I can't see any more questions there, so I think it's about time, and 10 minutes before the next session starts, so it's probably a good time to have a break. And first of all, thank you very much, Heather, for the presentation and for handling the questions that have come to you. Every bit as enjoyable as I expected it would be, and I think the irony was that the most difficult thing you find with an analyzer is trying to switch it on. So,
yeah, exactly.
Yeah, I think that was brilliant. So yeah, lots of love coming in on the chat there. So thanks again. Thanks to everybody for attending. You all obviously managed to get into the room. We've had quite a few people struggling with the IDs. I'll make the point now. The program, the timetable program that you got with the link from the email that you got has got all the IDs on it. Just use those to enter the rooms as you want to. So thanks again for everybody for taking part. I'm ending the session now, and we will see you later on in the day. And thanks again.
Hey Steve, just let you know that if there's any questions that became